Hello, my name is Won-Yong Jeon from Korea. I'm working at Sungkyunkwan University. Today, I will present my study titled Engineering Highly by Comparable Glucose Fear-Driven Enzymatic Field Cells. Before presenting, I will introduce my research network. I finished my PhD degree in chemistry from Professor Park Kim's lab, and I worked with Professor Haewon Kim, who is working for tissue engineering. I studied with him about enzymatic fuel cell treatment for cell cultures, and I joined Professor Namjoon Jo's group as an internship. Now I'm working in Sungkyunkwan University with Professor Joshua Janman for developing stability of enzymatic fuel cells. Today, I will show you about application of the fibril cell for cell culture. The chemical cell can be classification as follows. First is primary cell. It can be used to dispose food. We can see the secondary cell in our life. There is lithium-ion battery in cell phone or laptop. The primary and secondary cells are chemical cells. These are used metal as a fuel. Third is fuel cell, which can be using hydrogen gas as a fuel. This is environmental energy because the final product is water. Biofuel cell belong to fuel cell, and biofuel cell use biological source such as glucose as a fuel. This is environmental too, due to the water as a final product. Let me talk about why is the enzymatic biofuel cell. As you can see in the picture, there is enzyme which can oxidize glucose to gluconic acid, hydrogen, ion, and electron. A mediator rule is transfer the electron from enzyme to anode electrode. At that time, electron can be moving from anode electrode to cathode electrode followed conducting line. As you can see, the electron and hydrogen ion and oxygen can be changed to water by built enzyme. At that time, biofuel cell can make energy by continuous operation. Typically, enzymatic biofuel cell aims are as follows. The first is how can make power for operating implantable machine, such as artificial organ, pacemaker, biosensor, and drug delivery system. Second is how to increase lifetime of EBFC for long-term operation. These are main work in electrochemistry field. But in my case, I focused on biocompatibility of the EBFC before implantation. This is my first motivation. The biofuel cell has been applied to implantation power source for operating. So many researchers have been inserting the EBFC at dog, sheep, grape, and rat, snail, lobster, clams, and cockroaches. As you can see, a real biofuel cell inserted in ear, neck, and stomach. And then they are tracking machine operations such as pacemaker and smartwatch. However, I had a question: is it real biocompatible? What about cytotoxicity into the cell level? I couldn't find paper enzymatic biofuel cell cytotoxicity. I will show you results soon. And this is the second motivation. What about EBFG effect with the biological cell? As you know, we have been received the treatment, electrical stimulation when we have muscle pain from long times ago. Biology has been measuring electrical value of the skin. Nowadays, it was reported that small electrical current is helpful for cell. As you can see, the chemical cell and electrical potentials are trying to give the electrical stimulation to the cell. However, this kind of system has drawbacks such as hard control, big size, and inconvenience. On the other hand, the enzymatic biofuel cell has an advantage like this: applicability, self-generating, easy to use, using biosource as a fuel. So in this study, I'd like to know cytotoxicity of the EBFC into the cell level, and what is the EBFC effect to the cell therapy. I will show you about my research work. This is my total concept. As you can see, A, preparation of the EBFC. We made the EBFC like this. We coated the carbon onto the OH film and then covered tape. Left part is anode electrode and right part is cathode electrode. I used the enzyme redox polymer and cross-linker for making. As you can see, the EBFC is flexible due to the OHP film, so it can be bent very easily. Also, people can use it easily for cell culture. This is a very well plate for cell culture. You can see the mechanism of the EBFC. Anode parts produce the electron hydrogen ion, and cathode part consume electron and hydrogen ion to make water. So this is a very environmental energy generator. When the cell grows in middle site, biological cell can be proliferated by electrical stimulation. Finally, I observed the biological result. So I divided three groups, A, B, and C, are different concentration of the enzyme. A has a high amount of enzyme, 10 units onto the electrode. C has a low amount of enzyme, 0.1 unit onto the electrode. And then I measured the electrochemical characterization, ligand that image, cell viability, hydrogen peroxide concentration, and cell migration. This is the electrochemical result of the EBFC. As you can see, GDHA cyclovoltammetry result showed a high increased current between PBS and glucose. Because GDHA includes high concentration of enzyme, so it can make energy more than less enzyme like GDHC. In case of BOD, glucose is not main factor for increasing current density. In summary, GDHA-based EBFC has high power compared with GDHB and GDHC. So I inserted the EBFG into the cell culture dish with the human donor fibroblast cell. Human donor fibroblast cell is known well as a very common for checking cell viability. So this is a live and dead image. Live and dead image can be showing cell viability. Green color is live cell and red color is dead cell. As you can see, all conditions show the good cell proliferation compared to control. However, in spite of similar current with GDH group, GOD-based all conditions show the cell cytotoxicity in live and dead image. It means there is a dangerous factor in GOD-based EBFC. As you can see, the cell viability, GDH-based EBFC showed good viability. Unfortunately, all GOD-based EBFC showed cell cytotoxicity. Based on GOD oxidized mechanism with glucose, there is hydrogen peroxide as a final product. As you can see many reference, when the high concentration of hydrogen peroxide exists, HDF cells died over 750 micromolar. A graph showed the cell viability ratio compared with control. When I checked the hydrogen peroxide, concentration after inserting EBFC for 1 day, all GOD groups showed over 1,300 micromolar of hydrogen peroxide. However, GDH-based EBFC generated no hydrogen peroxide. This is very important when we make EBFC. People should consider GOD enzyme in anode electrode very carefully. Probably it might be making problem when we apply it to implanted material. And I think there is other EBFG effect for the cell behavior. I checked the mobility of the cell from migration test. As you can see, the result after 12 hours, GDHA group cells were more covered than culture. It means when the cell received high electrical stimulation, they used to move faster than culture. So I guess that it can treat skin therapy simply like wound healing. As a summary, this result showed the GOD-based EBFC has cytotoxicity because of hydrogen peroxide. Some people reported that if they use the catalysis, hydrogen peroxide can be decreased. But I didn't consider other material. So if you want to make implantable EBFC, you need to consider enzyme carefully. Finally, the GDH-based EBFC showed no cytotoxicity and good proliferation and migration. This EBFC would be using as an alternative material instead of electrical device or chemical cell. And now I'm preparing for wound healing test, and I'm expecting skin regeneration by EBFC. So now we are trying to animal test for wound healing. If then it can be more helpful for skin therapy. Now I'm focused on how to improve the stability of EBFC. I'm really appreciate for all my group members and collaborators. Thank you very much for your attending.